In this video, I'm going to go ahead and talk about section 2.3. Many of the graphs that we see in the media are misleading or can deceive us. So sometimes they are incorrect. Sometimes they are technically correct, but if you're not paying attention, you might miss little tricks that are done to get the reader to see this certain viewpoint when there's actually not even that much going on. So I'm starting on page 100 of your book, and then I'm going to go ahead to the next page. So here we're looking at the Berkeley graph in 2009, and we can see the percents along for the percents along the x-axis. They went ahead and put the months over here on the y-axis. Now what's interesting is they grouped July and August together, but they put all the rest of the months over here together. So they should just break it out by month. So it looks like there's more burglaries or larger percent occur in the summer when you look here and you divide out over all the months. There's really not much change. So anyway, this first graph actually is technically incorrect. You can't do that. But this is the more correct graph, and again, it's less interesting. So you want to watch for things like that, how the data has been grouped before the graph has been made. So if we go to the next page, this one here, this is the opinion regarding the, I think, the Skyvo case. So this was a very famous case. I believe it was about taking a woman off life support. And they were saying that the Democrats were leading here with a 60%, and they supported the removal of the feeding tube, where the Republican independents, they weren't very much for it, or less a percent. But if you look here, that it's starting at 53%. So if we were to start this graph at 0% along the y-axis, you wouldn't see much of a difference in these bars, but it's exaggerated because it started at 53%. Now, this isn't incorrect. This is something you can do. But as a consumer or as a reader of graphs, you're going to want to watch for this. So if you see a big discrepancy in the bars, you're going to want to look to check the scale and make sure it's starting at 0. And here you can see where they've actually done that. And you can see that the Republicans and independents weren't too far behind the Democrats. All right, this is the average SAT math score over time. And again, we're looking at the graph here, and we can see that this graph is starting at an SAT score of 495 instead of 0. So it's emphasizing that these scores have gotten better over time and then somewhat stabilized. But if we look down here, even starting at 200, they probably should start at 100, but even starting at 200, you're going to see not much of a difference in SAT scores. Usually, it's better to go ahead, they call this a time series graph, or just when you have years, it's usually better to put it on a line graph and then go ahead and graph it. And you'll see here that they have this squiggly mark here, and it indicates that the scale's been truncated or missing. So it emphasizes it a little bit more. But again, by not starting at 0, it looks like there's more of a difference in the scores over time than there really is. Anytime you see a graph with pictures, they tend not to be true to scale. So this one's looking like shoes are just like a little bit more than they use a shoe as compared to acting normal compared to using a paper towel. So this is what people were using to flush the toilets. But these aren't drawn to scale, which is also an issue. So sometimes when you see graphs made from pictures, they'll do that. And for this one, I don't think they share a correct graph, but you want to watch for that. Any pictures, same thing with this one here with soccer participation. It looks like there's a lot more soccer participation in 2007 because they drew the ball so much more larger than the ball that they drew in 1991. But if you look at the actual data, again, you won't see this disparity because they tend to draw pictures much more distorted. So here's the same data drawn differently with soccer balls, each representing 1 million participants. And you can see that while soccer participation has increased, it hasn't dramatically increased as much as they are trying to portray when they're using that large soccer ball versus the smaller soccer ball. And for the last one, let's go ahead to the next page. Here's another trick that they use. They use 3D bar graphs to represent the data. So whenever you're making a bar chart, pie charts, you might be using Excel, don't choose the 3D option because it kind of distorts the facts, and you don't know if you're looking at the front of the bar or the back of the bar to kind of pick up the data. So you can see here where they talk about it draws attention, user attention, but the bars seem to stand out more than the data they represent. The perspective angle of the graph makes it difficult to estimate the data. Resulting estimates are typically lower than the true values. So there's a concern there again. So instead of making a 3D graph, you want to go ahead and just keep with your 2D graph. So you can see now, for some reason, I'm generating an error with our textbook, which is actually very unusual, but I'm going to go ahead and end this section here. So again, when you're looking at this misleading graphs, and you'll see some on your homework, you want to watch that y-axis, watch for it to start at 0, make 2D graphs, not 3D graphs, and watch for picture graphs. They tend to distort the pictures and make one picture much larger than the other. They're not proportional to convince the viewer of their position.